Dear friends, I am Dr. Tamrakar. I will teach you food machinery. Now continue with yesterday's topic. Here the force exerted by the jet in direction of motion by the jet in direction of motion jet in direction of motion Fx is equal to mass of water striking per second, mass of water striking per second into initial velocity with which the jet strike in the direction of motion, jet strike in the direction of motion minus final velocity of jet in the direction of motion So here, but we know initial velocity with which the jet strike the when initial velocity is v(r1). Initial velocity with which the jet strike the whale is v(r1). So the component of this velocity in direction of motion is equal to v(r1) cos theta, that is equal to v(w1) minus u1. Similarly, the component of relative velocity at outlet in direction of motion is equal to minus v(r2) cos phi. So this comes minus u2 plus vw2. These are clear from the triangles of the inlet and outlet triangle Here negative sign shows that the taken the component VR2 in the direction of motion is in opposite direction to that of the jet. Now substituting these in the equation, the fx equal to rho a v r1 multiply v w1 minus u1 minus u2 plus vw2 so these are rho a vr1 vw1 minus u1 plus u2 minus vw2. As we know here u1 equal to u2 because u1 equal to u2, so this value of fx is equal to rho a vr1 vw1 minus vw2. Here in this equation it is true only when the angle beta shown in the triangle is an acute angle. If this is for angle beta, acute angle. If angle beta is equal to 90 degree at that time, so vw2 is equal to 0. At that time this fx value of fx comes rho a vr1 vw1. This is the equation when beta is 90 degree, means outlet is at right angle, the value of beta. When beta is obtuse angle, at that time fx equal to rho a vr1 and vw1 minus vw2. We can combine these both the equation as fx equal to rho a vr1 into vw1 plus minus vw2. This is the combined equation. And now the work done per second on the brain by the jet. For work done per second, this is force into distance per second in direction of force, distance traveled per second in direction of force, in direction of force. So here the value of force is Fx. The value of force is Fx into U. So by putting the value of Fx, that is rho A V R1 into VW1 plus minus VW2 into U. Now work done per second per unit weight of fluid striking per second. Work done per second per unit weight of fluid striking per unit weight of fluid striking per second. This comes rho A VR1 VW1 plus minus VW2 into U, that divided by weight of fluid striking per second. Weight of fluid striking per second. So by putting the values, this is rho A V R1 V W1 plus minus V W2, that divided by G into rho A V R1, G into rho A V R1. So this comes 1 by G V W1 plus minus V W2 into U, and the unit is Newton meter per Newton. This is for the water fluid striking per second. Here these are cancelled. Okay, so this is 1 by G VW1 plus minus VW2 into U. Next, work done per second. Work done per second per unit mass of fluid per unit mass of fluid. Here mass, main important is here mass striking per second, striking per second. This comes here the value of work done in mass of fluid. Earlier we have calculated the unit weight of fluid striking per second. Earlier we have calculated, and here the mass had considered. So this is rho A VR1 into VW1 plus minus VW2 into U by mass of water striking per second. Mass of fluid striking per second. Fluid striking per second. Here mass is considered. So the values here rho A VR1 VW1 plus minus VW2 into U, that is divided by rho A VR1. So this cancel, these are cancelled. So the value here VW1 plus minus VW2 into U Newton meter per kg. Here unit is Newton meter per kg. This equation gives the work done per unit weight, whereas other equation gives the work done per unit mass. This is given work done per unit mass and earlier is per unit weight. Okay. Now we have to calculate the efficiency of jet. As we know, efficiency is equal to output by input. So here work done per second, or when is the output? Work done per second on when is the output, and the initial kinetic energy per second of the jet, per second of jet. So by putting the values here, this is work done is rho A VR1 into bracket VW1 plus minus VW2, and that multiplied by U is divided by half of m V1 square. V1 square is the initial kinetic energy per second, and here mass is m is mass of fluid per second in the jet, so that is rho A V1, and V1 is initial velocity of the jet. So here eta efficiency is equal to rho A VR1 into VW1 plus minus VW2 into U, that all divided by half of rho A V1 is in place of mass and V1 square. This is the efficiency of work done on the jet. Here this is the efficiency. In this I want to clear that in the inlet here we have to calculate the VR1 with which the jet inlet in the van. So the component here in direction of jet is VR1 cos theta. This is the component, that is VR1 cos theta. So we have to find out this value. This can be replaced by VW1 minus U1. So this is VW1 minus U1. This we have used in our calculation that I have told in the inlet triangle and outlet triangle. And at the time of outlet, here the value VR2, here we have to find the VR2. So here the components in this direction are VR2 cos phi. Here direction is negative because this component here come in the negative direction as compared to the jet. So this value VR2 is the addition of U2 plus VW2. So these values are used while solving this equation, and with these questions, these triangles are very important while solving the questions, the inlet triangle and the outlet triangle. So by using these all, we can solve number of questions. This is most important. Each and every year the questions are asked from this chapter. So better you solve some questions from the question paper of earlier year, that will be good. And sometimes this derivation also asked, so you have to practice this multi times for solving this derivation. Thank you. Dear friends, I am Dr. Sasikant Tamrakar from Bharati Group of Colleges, BCET, Durg. I am teaching food machinery in your BE 5th semester. Today we will start some numericals on the plate inclined, and the jet is tangentially striking the plate.